Hi everyone, and welcome to the third of 5 videos going through some past paper questions on buffer solutions. This question is asking us about the buffer solution in the blood, and it is one that you are actually expected to know a little bit about. So the buffer solution in the blood helps keep the blood at the appropriate pH in your body, and it's based on carbonic acid. So as it says here, healthy blood is buffered to a pH of 7.4. and it's a mixture of carbonic acid and hydrogen carbonate ions. And the actual question here is the same as one we've seen in a previous video, it's just linked to this particular example. So it's explaining how this acts as a buffer solution. So the first thing we want to do is, it says explain how the equilibrium allows it to work. So we need to actually write this equilibrium out. So it's just the equilibrium for this carbonic acid dissociating. Okay, so it's going to make these hydrogen carbonate ions and obviously H plus ions. We're going to get a mark for doing that. It's a 5-mark question, by the way, which is very similar to what we saw on one of the previous videos. And now we just need to explain how it's going to work. Remember, a buffer solution minimizes the pH changes when small amounts of acid or alkali are added. Okay, so when acid is added, the H plus ions can react with the hydrogen carbonate ions that are here. And so therefore, we're doing the reaction between these two and the equilibrium is shifting to the left. So when acid is added, H plus ions react with the hydrogen carbonate ions and the equilibrium shifts to the left. And this is always the same way round. Okay, whenever you add acid to a buffer solution, assuming you've written your equilibrium with the acid dissociating, which you would do, then adding the acid is always going to shift the equilibrium to the left. And then you can see where this is going. When we add alkali, it's going to be the opposite. So when alkali is added, the OH minus ions from the alkali react with the actual carbonic acid itself. And therefore we're reacting, it's going to react with the carbonic acid and it's going to produce hydrogen carbonate ions. The OH minus ions will take a proton off of this, and so it will leave us with this. And so therefore the equilibrium is shifting to the right. Now we could also explain this point by saying that OH minus ions react with H plus ions, and then more carbonic acid then dissociates to reproduce the H plus ions. You could explain it that way. That would also be absolutely fine. But that's it. That's actually all we need to do to get our 5 marks. We got 1 mark for the equilibrium, 1 mark for saying what they'll react with, and 1 mark for saying the direction of the equilibrium shift. And then the same when you add alkali, the same 2 marks there. So this should hopefully be a nice question that you can look forward to. I mean, they've given you an enormous amount of space here that you really don't need to fill up. Okay, so don't feel pressured into going, oh God, I've got to write loads. Just be accurate. That will get you all the marks. Okay. Right, the second part of this question is a little bit unusual, although this type of question does come up every once in a while, so it is worth being prepared for. It's a question where it's talking about some sort of ratio. Okay, so if you ever see an acids question and you see the word ratio in it, it's the same type of question every time. Okay, so I just want to show you how to do this type of question. So they're saying the blood is healthy, it's at a pH of 7.4, and the ratio of hydrogen carbonate ions to carbonic acid is 10.5 to 1. Okay, if you say so. A patient is admitted to hospital and the patient's blood has a pH of 7.2, so it's not looking good for this guy. But they want to calculate the ratio in his blood, or her blood, doesn't say, very sexist. So where do we even start? We always start with these questions in the same place. We start with Ka. If it's some sort of acids question, write out Ka. So here it's going to be H plus, HCO3 minus, and H2CO3. Right, and then we want to have a look at what do we actually know here. We know that healthy blood should have a pH of 7.4, so we can use that to work out the H+ concentration. And we know the ratio of these two things is 10.5 to 1. So actually I can put that in here and calculate this. So the only one of these that I don't know is the Ka. So that must be what I'm supposed to be doing. Okay, so that's what we're going to do here. We're going to say that the Ka is going to be equal to, well, if the pH is 7.4, then the H+ concentration is going to be 10 to the minus 7.4. And then we don't actually know these concentrations, but we know the ratio, and that's actually all we need, right? We're just going to go, because we're just going to put numbers in here. This could be 10 and 20, or it could be 100 and 200, and it's going to come out as the same answer. So it's only the ratio that matters. We know it's a ratio of 10.5 to 1. So we can put that in and we can calculate the Ka. So let's have a go at that. We're going to say 10 to the power of minus 7.4 times 10.5 and divided by 1. That's pointless. So the Ka value is 4.18 times 10 to the minus 7. Okay, but I'm going to keep the whole number on the calculator. Right, then it wants us to calculate the hydrogen carbonate to carbonic acid ratio in the patient's blood. So what we're looking for here then is this ratio between these two. We now know what the Ka is, and we can work out the H+ concentration in the patient's blood from the pH. So we just want to rearrange this to get this ratio now. So all we need to do is divide by H+, because we can say that the Ka divided by the H+ concentration will be hydrogen carbonate over carbonic acid. Yeah, and this ratio is what we want. Yeah, this is a fraction, but fractions and ratios are basically the same thing. I'm not a mathematician. I'm sure some mathematician is going to take issue with that. But, you know, a fraction of a third is a 1 to 3 ratio, right? So now we can put numbers in here. So we can calculate this. We know what Ka is. And the H+ concentration in this person's blood is going to be 10 to the minus 7.2 instead of 10 to the minus 7.4. So we can just calculate that. And because I'm a genius, I've kept the number on the calculator from before. So I'm just going to divide that by 10 to the minus 7.2. So we've got 6.63, let's call it. So how do we turn this into a ratio then? Because that's not a ratio, it's just a number. But what we're saying, this divided by that is 6.63. So it's a 6.63 to 1 ratio. Okay, and there's no need to try and get this into a nice whole number. It doesn't need to be a 3 to 1 ratio or something. We don't need to get it to whole numbers. You know, they didn't give us a ratio that was whole numbers. So there's no obligation for us. We'll just leave it as it is. So the hydrogen carbonate to carbonic acid ratio is 6.63 for the hydrogen carbonate. So it's 6.63 to 1. Is that okay?